Hi everyone, today we will continue with chapter 10 Solution of Triangles discussion on self-practice 9.10. Now we look question number 1. In an examination hall, the tables of Daniel, Darwin and Cindy are at position A, B, C. So A is Daniel, B is Darwin and C is Cindy. These 3 points form a triangle as shown in the diagram on the right. The distance between Daniel's table and Cindy's table is 10. Daniel's table and Darwin's table is 4.027 meter, whereas Darwin's table and Cindy's table is 6.575. Prove that the sum of the interior angles of the triangle form is 180. That means you have to find angle here, angle A, angle B, angle B and angle C. You find one by one, then you add up, you must get 180. That is how you prove. So first we find angle A. You can use cosine rule to find angle A. The opposite is 6.575. So you use cosine rule, 10 square plus 4.027 square minus 6.575 square over 2 times 10 times 4.027. So you get angle A equal to 25.01. Same goes for for angle B, use cosine rule. And then also for C, also you use cosine rule. So you get the angle B is 139.98 and C is 15.01. You add all these three, so you will get 180. So you already proved that the sum of this angle is 180. Next, for question number 2, the diagram on the right shows a children's toy in the shape of cone and its upper portion is cut off. When cut off, you can see this like a circle. The surface in the shape of circles, centered O and centered P. So at top here is O and bottom is P, horizontal and the OP axis is vertical. There's a straight line that joins A to C, given OA is 5, PB is 10, OP is 16, and angle BPC is 90. So this is the diagram you can see here. So we have M here. When you draw a straight line from A to the line BP, we label it M here. So why we want to label it M? To find the length of M to C. So because this is ACM, okay, from here ACM is a right angle triangle. So we want to find the length of MC. That means we can use theorem Pythagoras. 5 is this one OA, that is from MAMC. So 5 square plus 10 square. Okay, I can label here 5 square plus 10 square. This is your MC. So MC is here is the value of X. This is the triangle. And P is 5. PC is 10. The triangle at the base here. MPC. So from there you find the value of X, that is MC. So you get a square root of 125. Then when you get MC here, so you know AC is 16. So again you use theorem, Pythagoras theorem to find AC. So you square it of 16 square plus 125, you get a 19.5192. Next, for part B, the area of plane ABC. Okay, the area of plane ABC, first you can label it AB here as the length is SY. So again, by using Pythagoras theorem, 16 square plus 5 square, this is your AB here. 16, that means from A to M, and from M to B is 5. Okay, because B to P is 10, so MP 5, BM also 5. So using theorem Pythagoras, we get 16.7631, and BC, again by using theorem Pythagoras, okay, BC we use 10 square plus 10 square. That means the triangle that is at the base, BPC. So PC, 10, 10, 10 square and 10 square. So you get, this is not M, this we can label it as P. Okay, so you get 10 square plus 10 square, so 14.1421. So by using now Heron's formula, you can find ABC, the triangle. You know the length of AC that we find in part A, 19.519. Then you know the length of AB that you find just now, 16.7631. Then you know the length of BC, that is 14.1421. So you find semi-perimeter, then use Heron's formula. You will get the answer 115.865. Next, question number 3. The position of two towns A and B are shown in the Cartesian plane in the diagram. Find the angle between the position vector of town A and town B relative to origin O. Hence, find the area of the region in the shape of the triangle OAB. So this one you need the uh, knowledge on vector. Negative 4, 3. That means the vector will be negative 4, 3, OA. Our OA will be negative 4, 3. B, the coordinate is 1, 1. So the vector OB will be 1, 1. So first we find the magnitude OA, that is 5. How you get for negative 4 square plus 3 square? Then you square it, you get 5 by like Pythagoras theorem. Also OB, 1 square plus 1 square, you get square root 2. So that is the length of OB, square root 2. And OA will be 5. Now we find the length of AB. So you want to find the length of AB. You find first the vector AB. Okay, it's a straight line, no? AB. So you find the vector AB. How you get vector AB? That is AO plus OB. So AO is OA is negative 4, 3. So AO will be for negative 3. Plus with 1, 1. So you get AB is 5, negative 2. So you find the magnitude. Magnitude actually is the length of AB. So you get square root 29. So when you get the square root 29, so now you want to find the area of the region. Here we find the angle AOB first. AOB by using cosine rule. So you will get the angle AOB here is 98.13. Then using half times 5 times square root 2 sine 98.13. So you get 3.5 unit square. But another formula that you can use is, you know, all the sides AB, OB, and OA. You can another formula that you can use is the Heron's formula. You find the semi-perimeter, then you use Heron's formula. Also can, you will get the same answer. So I hope you understand all the explanation given. Thanks for watching.